Hello everybody. So today I'm going over another TryHackMe lab. This is going to be the Linux Fundamentals Part 2. It's another pretty basic, just foundational knowledge in Linux, just like Part 1 was. So going to the introduction. So welcome to the second part of the Reworked Linux Fundamentals series. We'll be applying our knowledge from the first installment of the series, so it is very recommended that you do actually complete Part 1 before moving on to Part 2. And in Part 2, we'll be ditching the in-browser functionality to help you get started and what is a fundamental skill in being able to log in and control the terminals of remote machines. So not only this, but the room will also have you unlocking the potential of your first few commands by introducing you to using flags and arguments, advancing your knowledge of the file system to perform some more useful commands such as copying and moving files, discovering how access to files and folders is managed and how we can determine our access, running your first few scripts and executables. Task 2, setting your Linux machine using SSH deploy. The in-browser functionality was used in Linux Fundamentals Part 1 to get you just directly connected to your first level Linux machine without any sort of hassle or having to log into anything. In fact, the in-browser functionality used the exact same protocol that we're about to be using today. So this protocol is called a secure shell, or SSH for short, and it commonly means connecting to and interacting with the command line of a remote Linux machine. We'll be deploying two machines in this room, so your Linux machine and then the TryHackMe AttackBox. So the AttackBox, so with a lot of these rooms, you'll have a button up here that says Start AttackBox. I already went ahead and started it because it can take a few minutes to start up. And then you will also have to hit Start Machine, is what you have to do with a lot of these labs in TryHackMe. Okay, so what is Secure Shell and how does it work? Secure Shell, or SSH, simply is a protocol between devices in an encrypted form. Using cryptography, any input we send in a human-readable format is encrypted for traveling over a network, where it is then unencrypted once it reaches the remote machine, such as in the diagram below. So as you see here, it said your computer, hello world, the internet, and then this is how it actually reads over the internet. And then once it goes to the Linux server, it reads back to hello world. So this helps it while your data is in transit, because that is going to be when your data is the most vulnerable. You can have things like man-in-the-middle attacks. You can just have a lot of different types of actual attacks where people can steal your data while it's moving from the source to the destination. You can learn about various types of encryptions on TryHackMe Room, but for now we only need to understand that Secure Shell allows us to remotely execute commands on another device remotely. Any data sent between devices is encrypted when it is sent over a network such as the internet. So use an SSH to log into your Linux machine. So first what we're going to have to do is find the IP address of the remote machine. So to find that, just have to go right up here. I'll go ahead and copy that. And head back down here. So for this room, we'll be logging in as TryHackMe, whose password is TryHackMe, without the quotation marks. So let's use the IP address. So let's just go ahead and type this in. So it's going to be SSH TryHackMe at, and then after that, I will then put in the IP address. And then this is going to prompt me, are you sure I want to connect? Yes, I want to connect. And the password is TryHackMe. And this will allow me to get into this Linux server remotely. So I've logged in Linux Fundamentals Part 2 using SSH. And, okay, I did. Introducing flags and switches. So majority of commands allow for arguments to be provided. These arguments are identified by a hyphen and certain keywords known as flags or switches. We'll later discuss how we can identify what commands allow for arguments to be provided and understand what these do exactly. So when using a command, unless otherwise specified, it will perform default behavior. For example, ls, that's something we went over in the last lab. It lists the contents of the working directory. However, there are hidden files that are not shown. And that's what we'll actually get into in a second. So using the ls, it's going to inform us about only the folder name folder1. So what's going over here? So if I do ls, It's going to show important, my file, my folder, unknown one. And now what is going over right here, so if you use the argument A, it's short for -- all, and it's now going to output the actual hidden files. And the hidden files, I'll show you. So the hidden files are identified by this period right in front of the actual file itself. So even right here, we could still read it as long as there's something that is there to read. And that's something that I would not have been able to actually see without doing the ls-a command to see the hidden files. So commands that accept these will also have a -- help option. So this option will list the possible options that the commands accepts. So the other thing, if you don't remember all the commands, I mean, there's plenty of ways to do it, but if you only have access to the system that you're on, you can do -- help. And this will just go over a list of commands that you could use that would go with the ls command. So like what we just did here, let's go all the way up. So like the -a, so do not ignore entries starting with the period. So that's your hidden files. So that's what we just did. And then you could do all these different commands as well to go after ls. So you can do -h, human readable. You can do a lot of different things with the help option. There is also other ways you can do as well. You can always do Google searches. You can look on forums. You use ChatGPT. There's an infinite amount of ways to find commands that you will need. But this is the simplest if you only have the terminal itself to go on. And once you actually do know how to navigate the terminal, it does make it a little bit easier versus doing a Google search. Okay, so after the help option, you do have the man. Well, it is called man is the actual command, and that stands for the manual page. So what you would do to access that, man, and then whatever command you're trying to get more help on, you do that afterwards, like the ls. And what this is doing, it's doing the same exact thing as the help command was doing. It's just showing me the actual manual, and I can go back. I could search through all of it this way as well. So that's just another way to find any extra command you may potentially need if you get stuck on anything. Okay, and now to get past that one, so exploring the manual page of the ls command. So what directory arrow would show, so what directional arrow key would we use to navigate down the manual page? So that one is just going to be down. So if I do that again, I'm just hitting the down key. I can also hit the up key. That's bringing me up and down. Pretty simple, pretty self-explanatory. But if you are on an actual server or some sort of system that doesn't have a mouse you can connect to, which not all servers, I mean, every single system is not going to have that option. So you will have to be able to navigate through it using the directional keys. So what flag will we use to display the output in a human readable way? So let's just do ls. I don't really feel like going into the whole. I don't feel like going to the manual page. I'll just go to the help. For me, it's just easier for me to go through the help than it is the manual page. So I'm looking at H right there, so human readable. So that will be the flag that you will display the human readable. Well, that would be the flag used to display the output in a human readable way. So task 4, the file system interaction continued. We covered some of the most fundamental commands while interacting with the file system on the Linux machine. For example, we covered how to use list and find the contents of the folders using ls and the find command, and navigating the file system using the cd change directory command. In this task, we're going to learn some new commands for interacting with the file system to allow us to create files and folders, move files and folders, and delete files and folders. And this right here, so this is going to be a list of commands. The touch command, that's going to help you create a file. The mkdir, make directory, that's creating a folder. cp, copy, creating a file or folder. MV is move, that's moving a file or a folder somewhere else. RM is remove a file or folder. And file is just determining the type of file that it is. Creating files and folders, touch, make directory. So creating files and folders on a Linux is a simple process. First, we'll cover creating a file. The touch command takes exactly one argument, the name that we want to give the file we created. For example, we can create a file called note by using the command touch note. So before I get into creating the file called note using the touch command, I should just show you that there is no file on there called note. But once I use the touch command, you can see the note file is in there now. So this is a similar process to making a folder, which just involves the using make directory command, again providing the name that we want to assign to the directory. For example, we can create a directory called my directory. So as you can see in here, so the directories in here, it would be these dark blues right here, so my folder, and all of these right here are just files. So mkdir, my directory, and now my directory is in here. And the actual file folder, they're not going to be called my directory or my file. They'll be called something realistic to life. But these are just great examples to show you the basics of how all this works. So removing files and folders. So RM, so that's going to be removing. So what I can do on here, what it's telling me, however, you need to provide the -R to remove. And that's for the directory. So for the note, you just do RM note. As you can see, note's no longer in there. And for the directory, how it's saying to do the directory is my directory. And what I'll actually do as well, I'll show you another way you can remove the directory. My directory. So I put my directory back in there. And now what I'm going to do, rmdir. And that's just another way you can do that. I personally prefer to do it that way, but you or somebody else may prefer to do the -R command to do that. Copying and moving files and folders. So CP is copy, MV is move. Copying and moving files is an important functionality of the Linux machine. So starting with the copy command, this takes two arguments. It's going to be number one, the name of the existing file. Number two, the name we wish to assign to the new file when copying. So CP, so in here we don't have any other file. I'll just make another one, touch note. And note should be back in there. Okay. So copy, CP, note. We're copying it to be note 2. So now you can see both note and the copy of note 2 is in there. So making a file takes two arguments, just like the CP command. However, rather than copying and or creating a new file, MV will merge or modify the second file when we provide as an argument. Not only can we use the MV to move a file to a new folder, but you can also use MV to rename a file or folder. So for example, in the screenshot below, we renamed the file note2 to be named note3. So this MV note2 and renaming it to note3. And as long as it was done correctly, yes, it was done correctly. Now note2 got renamed to note3. Or if you don't want it to be that similar, you do MV note2 to TryHackMe. Oh, that's right, my bad. So MV note3 TryHackMe. There we go. Now we got note and we got TryHackMe. So determining file types. What is often misleading and often catches people out is making presumptions from files as to what their purpose or contents may be. Files will usually have what's known as an extension. It's going to make it a little bit easier so you can actually see what the files should be or what they would be. So a text file would be .txt. Docs file, document files will be .docs, JPEG, .jpg. So it'll kind of go along those principles. So far, the files that we've used in our example, they haven't had any extension whatsoever. So without knowing the context of what the file is there, we don't actually know what their purpose is. So entering the file command, that will solve that for us. So we'll figure out exactly what type of file it should be using the file command. So what I'll do is file note. Let me actually put something in note right here. So echo hello. That way you can actually see this. So file note. So as you can see right here, the note document, it is an ASCII text. And what that means, it's an American Standard Code for Information Interchange. It's just a computer code that assigns numerical value to basic English letters, so your characters and your symbols. So that's the type of file that this would be. And how would you create a file named new note? So what I'm going to do is touch new note. So on the deployable machine, what is the file type of unknown one? Okay, so we're going to do file unknown one, and that is ASCII. So it's ASCII text. How would we move the file my file to the directory my folder? So how we're going to do that is mv my file my folder. What are the contents of this file? So the contents of my file, I can just do cat my file, and it's right there. So that is the flag that I need. So it's going to be thm file system. I'm going to go on to task 5. So task 5 is permissions 101. So as you would have already found out by now, certain users cannot access certain files or folders. We've previously explored some commands that can be used to determine what access we have and where it leads us. In our previous task, we've learned how to extend the use of commands through flags and switches. Take, for example, the ls command, which lists the contents of the current directory. When using the -l switch, we can see 10 columns, such as the screenshot below. However, we're only interested in the first 3 columns. So right there, this is actually the command, the ls-lh. So that's going to list the permissions in the directory itself. So although intimidating, these 3 columns are very important in determining certain characteristics of the file folder and whether or not we have access to it. A file or folder can have a couple of different characteristics that determine both the actions that are allowed and what users or groups have the ability to perform the given action, such as the following. So the read, write, execute. So as you can see over here, so this is what it means by the read, write, execute. If it shows you RWX in there, that means that particular person, they would have the ability to read, write, and execute and do anything with that file or that specific folder. Now what you're seeing right here, it's not going over it. This is the D. So this just is letting you know it's a directory. As you can see in my folder, that's a directory, and the rest of these are, well, they're just a file name. So briefly, the difference between users and groups. The great thing about Linux is that permissions can be so granular that whilst a user technically owns a file, if the permission has not been set, then a group of users can also have either the same or different set of permissions to the exact same file without affecting the file owner itself. Let's put this in the real world context. The system user that runs a web server must have permissions to read and write files for an effective web application. However, companies such as web hosting companies will have to want to allow their customers to upload their own files for their website without being the web server system user, compromising the security of every other customer. So if we put it in a more tangible, real world scenario to make it a little bit easier to grasp. So let's just take YouTube, for example. So here there's three groups. This is owner, this is group, and this is the other. So me, as the person who created this video and put it on YouTube, I have ownership privilege. So what I can do to it, I'm just going to go down here because I'll be able to do all three of these things: read, write, and execute. I can watch my own videos. I can edit them. I could add extra stuff to them. I could take them down. I can completely get rid of it if I want to. I can do whatever I want with it. It's my video. I have the permission to do that. Then we go over to the group right here. So the group, that's actually going to be YouTube itself. And now YouTube, they can't do anything to the original file itself. They can't modify it. They can't do any of that. But what they can do is they can watch the video as well. And they can also take it off of YouTube if I violate any sort of the community guidelines. So they could do that type of stuff. They can ban the video if I'm just doing if I'm just doing stuff I should not be doing. They could ban the video. And then you do have just the other group, that's just other. These are the viewers. These are the people that you can just watch the videos. You can't modify the video. You can't do anything, but you can watch the video. So that's what those three groups are, and more of a YouTube perspective. So switching between users. Switching between users on a Linux install is easy work thanks to the su command. Unless you are the root user or using root permissions through sudo, then you are required to know two things with facilitating this transition of user accounts: the user we wish to switch to and the user password. So the su command takes a couple of switches that may be relevant to you. For example, executing a command once you logged into a specific shell to use. I encourage you to read the man page for su to find out more. However, I will cover the -L or login switch. Simply by providing the -L switch to su, we start a shell that is much more similar to actual user login into the system. We inherit a lot more properties of a new user, i.e. environment, variables, and the likes. So we're saying right here, so we can see right here, I am currently in TryHackMe. I want to switch over to user 2. So what I could do is su switch user 2. It is prompting me for a password. I could try the password that they gave me, TryHackMe, but that password isn't working. It's not really that important that I actually get into it, but that's how you would do that. I just don't have the password for it, so I can't get in. And now, using su to switch to user 2 interactively. Now, after using the -L, our new session has dropped us from the home directory of user automatically. So what that is, I don't have a password again, but -L. And once again, it prompted me for a password, which I don't have. And time again just answering the questions. So on a deployable machine, who is the owner of important? So important, let's get out of that. ls, so let's do ls -lh. The owner of important will be user 2. I just not realized I even have to type that in again. I don't know why I did. I just like typing in commands. Well, with command B to switch the user to user 2. So that would be su user 2. Now switch to this user, user 2, using the password user 2. Okay, so here is the password. So I can do su user 2. The password is user 2. And now who am I? I'm going to see I am now in user 2. And now I could go around the files and everything in user 2. It's basically all the same. In a real world scenario, I'll have access to what they have access to now. Now I'll put the contents of important. What is the flag? So cat important is going to be thm su underscore user 2. Check. Now common directories. So common directories, what we're going to do here, I'm actually just going to go back to su TryHackMe. I'm back in TryHackMe. Who am I? Yeah, I just like to verify just to make sure I am actually where I'm supposed to be. So what I'm going to do with this, I'm going to go for a working directory. Where am I? cd. Okay. So the etc. So this is a root directory and is one of the most important root directories on your system. The etc folder, short for etc etera, is a commonplace location to store system files that are used by your operating system. So I could show you etc, and this is what would be in the etc file. See everything right here. You have shadow. A shadow just goes over a lot of different passwords. And it goes over host. Just this is what the etc file is. So for example, the sudo user file highlighted in the screenshot below contains a list of users and groups that have permissions to run sudo or a set of commands as the root user. As highlighted below are the passwd and shadow files. These two files are special for Linux as they show how your system stores passwords for each user in the encrypted format called SHA-512. So this is what the SHA-512 is. It's the 512-bit digital fingerprint or signature for data. It's a secure hashing algorithm. And they do a lot of these hashes to protect data. It's not to protect it per se, it protects the integrity of the data. So with hashes, what you can do, you can verify the hash of a file, and if it has been altered at all, you will see that in the hash will be slightly different. So just to go over that really quick, what we'll do is so what you can do is SHA-512. Let me see real quick, just so I type in the correct one. So SHA-512 sum, and then I will type in note. And that right there is the actual hash itself. And now if I go into echo and I switch that around a little bit, echo hello world, note. Now I do SHA-512 again. You see right here, I switched this, so this verifies the integrity of it. You can see there's a little bit different. You can just look at the last three of this 512 SHA-512 hash. So that's what that does. I'm just going to clear this out. Now time to get back to this. So that's your etc. And the shadow, so this just stores files. And the var log, so the var directory is going to be short for variable data. And is one of the main root folders found in Linux installs. So this folder stores the data frequently accessed or written by services and applications running on the system. So for example, log files from running services and applications are written here as var/log, or other data that is not necessarily associated with a specific user. You can see in var, you have your var log, and then I'll just go over here. Now log, I can look at all of these different logs. You see here, I can now look at all these different logs, alternative log, see if it'll actually show me anything. Okay, it's not going to show me dpkg.log. Okay. So it's asking me, it's telling me permission denied, meaning I don't have permission to actually view this log. But if I do sudo, no, I wouldn't have a password for sudo. And then root, so this is like the home directory. The root folder is actually the home for the root system user. This isn't anything more to this folder other than just understanding that this is the home directory for the root user. So this, let me show you. Okay, I can't get into the root user, don't have access to that as well. But it's worth mentioning that logical presumption is that the user will have their data in a directory such as home/root. So the TMP, this is a unique root directory found on a Linux install, short for temporary. The temporary directory is volatile and used to store data that is only needed as accessed once or twice. So what volatile data means, volatile data is just data that you're using while the computer is running and it's on. And once you turn it off, that data is no longer on your computer. It's not saved on anything. So that's what the volatile data is. It is very similar to the random access memory that you do have in computers, where once you turn the computer off, all that memory, it's gone. All right, so readme, I read all of that. Here's the directory path that we would expect logs to be stored in. So that's var log. What is the root directory? This is similar to RAM on how a computer works. Just went over that, so that is going to be the TMP. What is the name of the home directory of the root user? Well, they have that question. And that should be about it for this lab. So that's just a quick conclusion. I just went over how we connected to everything through the SSH, went over a few different commands, went over the root file system. And if you do need any more practice with doing any of this, this is a little bit more complicated than the first Linux lab. So if you do need more practice, just go over it again and again and again. It's coming down, and it's etched into your head. So that's the only way you're really going to get good at this, is just repetition, repetition, repetition. And that's going to wrap it up for this video. So thank everybody for watching. I'll be doing another one in a few days as well.